Welcome to another GCBASIC update on the floats implementation. Let me just take you straight into IDE and get started. Okay, zoom out, there we go. I'm in the IDE, I've got open a folder that's called single variable type underscore solutions. It's in GitHub and in the demonstrations folder. There are 14 files in there. We'll walk through them very quickly. Okay, let's start with constant to singles. Okay, and this is just a really simple program. You dimension a variable called test single number as a single, and you then can assign a constant to it, and that constant can be a positive or a negative number. It can be poorly formatted, but it will just sort of put it on the screen. What it will also do is going to convert the new single variable that we've created and put that on the convert it to a string and then put that on the terminal because we're using the hserial print command. So I previously opened up, I'll move that aside. I previously opened up the terminal. Here it is. A value is on there from the previous run. And it says here the value is minus 127,99999, whatever. And that's what we've got here. So we've got a way of displaying numbers on the screen. If I change that to a positive, we'll just make sure it does the positive thing. So what we're seeing here is assignment of a single and string handling. You can actually extract that string out and do something with it. That's a very useful function for what you want to do. So how did I do that? My string. I've created a variable called my single. Sorry, I've assigned a constant to it, and then I put it on the screen. Very simple. Right, all these programs are in here. If you do the following, when you open them, they're probably going to be quite long, okay? But they all have the same header. So this header up the top can be deleted. So how do you get to that? Control A, function key F2, fold all, and then it will fold it, and it will take you back to this very short program. So if I do function key F2, unfold all, does that unfold, fold? Just press the wrong key, press function key F4, unfold, fold. I thought there was an unfold command, but never mind. As you come into here, you can sort of click on it and it will open up the file just to show you things. The moment you've opened it, you go, oh, that's boring. Control A, F function key F2, fold all, and it will fold it back. So you can delete this top part, just delete the bottom part. Okay, let's look at this. What's this going to do? This is mass and conditional tests. And what this does is assigning some values into a constant called myRadius, and then calculating the circumference and then showing that on the screen. And if it does, it's got some little other tests in there. And why am I doing these tests is because I'm testing out whether the conditional testing is working. So is this number greater than that? Is it equal to that or less than that? I can then press function key F5, and if it comes out with the right result, then we'll be laughing, won't we? So it says here, if it's greater than 10, equals 10.5, sorry, less than 10.5. Let's have a look at what it does. It says my radius is 10.5, the circumference is 66. Therefore, the radius is equal to 10.5, and it's calculated these. Oh, how's it done that? Let's have a look in here. It says that I have a single variable called my diameter, and I took my circumference and I divided it by pi, and then put that result on the screen. So we're doing lots of maths in here. How are we determining the value of pi? I've created a constant in a script called pi 22 divided by 7, and I've allowed the compiler to actually calculate the value of pi, and it's created a constant called pi. So this shows you quite complex use. You've got scripts to create constants, assigning of variables, mathematics, conditionals, and division. Good demo. We've seen that one. This is just to show you can do some formatting on the screen. It's just functioning out. Expand that there. This is just to show that you can do your own maths. You can do pseudo maths. You can do whatever you like in here. Hopefully it will work for you. Essentially what I'm doing is some pseudo mathematics to calculate 3 decimal places on my value without using the inbuilt functions. I'm doing that by longhand. And in here, you can see I'm assigning the single number to a result number. I'm repeating something 1,000 times. I'm adding it up if it's a positive or a negative motion, and then I'm setting the decimal value. And you could do I'm just doing formatting of strings in here just to make sure it all works. And out here, it says here that I've got an answer of 1.009. So what was my original number? My original number was this number here, 1.01. My answer was 1.009. That's very good to 3 decimal points. If I just take that off there, look. Because sometimes you don't want the full number coming back, but it's just to show you that you can do mathematical calculations. I'm just having a swig of coffee. 1.2799. So that's close enough for military work. Okay. Revert those changes so it's consistent. Close that one down. Now so far we've seen constants, assignments, strings, handling, but we haven't seen any deductions. So let's just do a deduction one. In here, do some work. It says there's an initial float value. I deduct it from 0. I want to see the answer. So initial float value. I deduct it from 0. I want to see the answer. You should be able to guess what the initial number was. When we see the terminal, that's the previous run. It was 3.142, of course. It was pi. Let's have a look in here from it. Here we go. I've hard coded that. I put it into my initial number just so I can sort of make sure that assignments are working. So you can put pi in short form, or you can let the compiler calculate it. This one's quite complex. Lots of tests going on here, but I'll walk you through it. We'll compile it up first, and we'll get it running. So what we've got here, we have some maths. We have some timing. Why is that just showing that? Don't know. That's the IDE. We're doing maths. We have a timer running. We have events happening. More maths, and we show the results. So what are we doing? I've actually got a timer running with an ISR, and it's also doing the maths to make sure that the maths survive the ISR attack. So when the ISR is running, you can actually ensure that the maths are correct. So it's just going through some very simple maths. Simple. What we're doing in the script, calculate a constant called pi. Initialized in the timer. So this is just basically setting it every 1 second, just running the timer, then it's calling an ISR at the bottom. And all that does is inside of here, it says, I'm running the ISR. Not good practice, you shouldn't do it this way, but I just did it. Constant loop is doing the following, assigning a single, doing some mathematics to calculate that. So if the ISR runs and interrupts, it'll make sure that the maths survive. Assign some pi, do some other maths. It's just really long haul maths to make sure that when the interrupt runs, and the interrupt is running at least every 5 seconds, because I put a wait in there for 5 seconds, it runs, stops, the interrupt's firing away, during the mathematics. So it's a very good way to show that the interrupts are working. Lastly, no, two more, three more. This is a mod test. This is to show that you can do mods, MOD, and here it is here. I've assigned a value to a start value. I put it inside of, I've assigned an initial value and the mod value. Then I've just put the initial value inside my other variable called start value because I'm going to destroy some values. I just want to reset things. So the initial value is shown on the screen using single to string. I then do the mod, and I've said my mod value is a single, and that's all it's doing. It's just going to take in the start value and doing a mod on it. And then here's a long method of doing the same thing. So here is a long method of doing it. So you basically take the start value, divide it by the mod value. You assign that result, the integer value of that, into a long variable. So I've only got the integer part. I've taken the start value and deducted the integer, which gives me the decimal part. And then I've multiplied the start value times that, and it will give me a lot. It will give me the mod. But obviously you'll probably want to use this command here, the mod. Let's have a look what it's done. Oh, it's still running the ISR. So basically, I'll just fold that down for us, get it out of the way. That's a single mod test, it's called. And it says here that it hasn't done it yet, it's just programming it. Is that the start value was 4.56, 213, and 217. We calculated it in the easy method as 2.46, and the long method is 2.46. So both results give the same. You choose how you do it. I know what I'm just making sure they both work. Okay. For next loops. Let's have a look at for next loops. For next loops, there is a constraint on a for next loop that they must be integers. That is what I'm going to show you here. And then I'm going to show you a way around that using any increment of any single value. Essentially, there's a for next loop here of 8 to 10.5 with a step of integer 2. Now, you can put a single in here and it will just complain and just say not valid. So all I'm doing is some maths in here to put it on the screen, and they're all prefaced with the number 1. So what we're expecting to see here is a value of 8, 10, and exit. It will not increment. It cannot increment because the for next loop only supports integers. That's the way it was written. I wrote it. So you want to get around that, do you? Well, you can do it this way. It's very simple. You say my radius equals 8, which is a single value, and then you're saying, right, while a radius is less than 10.5, or less than or equal 10.5, do the calculation of my radius times pi times 2, put that on the screen and preface it with the number 2. Increment my radius, it will then loop back, and it will do this multiple times in increments of 0.5. What's it say on the screen? Here it is, my radius, prefaced with 1, 8, and 10 with the circumference. Again, then it's going into the second phase, which is the do loop. So you can do the increments of 8, 8.5, 9, 9.5, 10, 10.5, and you get the results. So whilst there is a constraint for the for next loop, it can be easily replaced with the do loop. Control B, Control W to shut that down. Single to string, can you convert, seen that? We've got single to string. You've actually got string to, you've actually also got string to single, which I haven't shown you, but there's just no demo for that. Single to string, but essentially it's putting these numbers out on the screen for you, so you can see it running. And these are lots of examples of how you'd actually make that work, how you can use how you can use casts to ensure it comes out correctly. Because you might need to help the compiler with respect to that. And here are some results, not well formatted, but it's just basically says, here's what I've given it, and it's returned this value, 0.05, 0.05, 0.5, 0.5, 1.51, etc. So here is a decimal rounding. You can see occurring. I gave it that, and it's returned this. What is that rounding caused by? We can see that if we come into one of these, there's a website, floating point calculator. Let me look at what's in the terminal. I gave it this number, Control C. I'm going to put it into this calculator. It says the best it can cope with is the last digits here, 274, not 265. What did we get in here? 274. So what we got, what we're getting back from GCBASIC is exactly what you actually, the best we can store inside this type of float. Okay, and this last one is decimal rounding of 999. What does it think it should be in here? It says 10 million. 10 million. There you go. Okay, so it's correct. So what did I want to show you? I wanted to show you a whole series of simple programs that are available in the folder, a single variable type. We'll call that a wrap.